1992 AB1, we have the function f of x is 3x to the fifth minus 5x to the third plus 2. In part A, we're asked to find on what intervals f is increasing. F of x increases when f prime of x is positive. So how do we find where the first derivative is positive? We find out where it's equal to 0, and then we do a sign test on each of the intervals created by those zeros. So the first derivative is 15x to the fourth minus 15x squared, and that will be equal to 0 when 15x squared times the quantity x squared minus 1 is 0, and that last factor can also be factored further. And so we see there are three values of x that will make the first derivative equal to 0. Alright, so since the first derivative can only be 0 in those places, that means it only crosses the x-axis at those 3 points. That means then in between negative infinity and negative 1, the first derivative has to always be positive or always be negative because it doesn't cross the x-axis to change signs. And the same for the other intervals created there. Alright, so again, what we're trying to do here is to find out where the first derivative is going to be positive. So we found the first derivative and we created these 4 intervals based on where the zeros fall. And we select some test values in those 4 intervals, and we're going to substitute those test values back into the first derivative because we want to find out where the first derivative is positive. So we take negative 2, and I'm going to use the factored form. The first term, 15x squared, will always be positive. So plugging in negative 2 into the second and third, I get negative, negative, which will be positive. Plugging in 1/2, the first is always positive, the second will be positive, the third will be negative, so that will be negative. Plugging in positive 1/2, the first will be positive, second positive, the third will be negative, and so that will also be negative. Plugging in 2, I'll get positive, 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 which is positive. And so then we can see that the first derivative will be positive from negative infinity to negative 1, or from 1 to positive infinity. And that's it for part A. For part B, we want to find out on what intervals the graph is concave up. And f of x will be concave up whenever f prime prime of x, or the second derivative, is positive. So we need to find the second derivative and do a sign test very similar to what we did with the first derivative. Again, to find the second derivative, I'm not going to go back to the factored form because that would require a product rule with 3 different factors. Instead, I go back to the simplest form of the first derivative, and then I just take the derivative of that. So the second derivative will be 60x to the third minus 30x, and that will equal 0 when 30x times the quantity 2x squared minus 1 is equal to 0. And so we have x equals 0, and we have 2x squared minus 1 equals 0. So x squared is equal to 1/2. Now the mistake that most people make here is to say that x is equal to 1/4, but that would be the square root of 1/4 would be 1/2. Well, what we want is the square root of 1/2, and that would be plus or minus 1 over root 2, or plus or minus root 2 over 2. Okay, so we're going to set up a sign chart. Now for testing purposes, you should know that square root of 2 is roughly 1.4, and so root 2 over 2 is roughly 0.7. So I'll get the test values negative 1, negative 1/2, 1/2, and 1. And recall I'm going to plug those test values back into the second derivative because I want to find out where the second derivative is positive. And I'm going to use the factored form for that. The first will be negative, the second will be positive since both factors are negative. The third will be positive because both factors are positive. Sorry, the third term will be negative. The fourth term positive. And so the function is concave up on negative 2 over 2 to 0 and root